Hello, in this video, let's try to calculate the number of connected components in a graph. This kind of calculation is useful when we try to answer the question how many dots is on a photograph. So what I mean is like here I have a video game. The girl is asking you how many stars are on the sky. So in order to answer that question, we need to count how many white dots on that black background. The program to do that is here. First, we need to create a graph data structure. Once we have that graph data structure, we can count the connected components, and the counting is corresponding to how many stars on the sky. So let's take a look at the graph data structure. A graph data structure is boiling down to a map, which is a map between the current vertex and or its neighboring vertexes. That's all the graph is about, not very mysterious. And the constructor is like this. We read in the picture and we get the dimension. The dimension is used later to find the neighbors. And we create a hash map, and we iterate through all the pixels on the photo. If the pixel is a bright pixel, we add it into the hash map or the graph data structure. We also create an empty bag for the neighboring vertexes. And we iterate through the vertexes, the pixels again, and we ignore all those dark background pixels. And if we find a bright dot pixel, we increase the hit count. And here, this logic is like here. Given a current pixel, we want to find its neighboring pixels. If those neighboring pixels are also on the dots, we want to add an edge on the graph data structure. So it means those pixels are adjacent. Otherwise, say if this is a dark background, then this one first should be ignored, and they are not adjacent. And I also want to make sure the pixel, say if the pixel is here, we don't want to look outside of the photo, don't want to look here, look here. If it's on the edge, we don't want to check here because it's outside of the photo. That's this cluster of logic is about. Once we find a valid neighbor, we want to see if this is a bright bright pixel. If that's a dark pixel, we ignore it. If this is a bright pixel, we add edge. The add edge is nothing but put the neighboring vertex into the bag of the current vertex, and also put the current vertex into the neighbor vertex's bag. And now we connected two pixels together. Once we have the graph, count the connected components is easy. We just have to do a iterate through the vertices in the graph. And if we haven't visited it, we do a depth first search to visit all its adjacent vertices. So we first mark the current vertex as visited, and we mark the current vertex as belong to this union, the count is union number, union ID. And then we visit the current vertex's neighbor. If they are not visited, we recursively do the DFS and mark their neighbor belong to the same union. Once we exit this DFS, that means we already exhausted all the vertexes reachable from this starting point. So in that case, we find a union. So we increase the union ID and we search the next vertex until we exhausted all the vertexes in the graph. And at that point, the count is corresponding to how many connected components in that graph. So this is a whole program centered around this adjacency map. And let's come here. Let's watch tower game. Let's crop this image. Okay. Already have those. Let me throw it away. This is the one I just made the screenshot. I call it sky. Let's close this. Copy. Paste it here. I already have some, so let's donate. Paste. Okay. Let's read this. Read in the sky. Run as Java application. And we totally find 99 connected components. Is that correct? I know it's correct because that picture I created with HTML code. And on that night sky, we have 70 size 1 star, have 20 size 4 stars, and we have 10 size 9 stars. So totally they have 240 pixels. And the fact I find 240 pixels means I didn't miss any stars. I didn't miss any star from the photo. But why I get 99 instead of 100? Because some star could be adjacent. So they are counted as 1 instead of 2. In order to find that, I iterate through the union count. And I group them by the union size. I know the normal size is 1, 4, and 9. Any abnormal sized unions, I want to print them out. Actually, it print out as 2. That means only one possibility. I have two 1 pixel stars connected together and get a 2 pixel star. So 2 stars are counted as 1 instead of 2. That's the reason I get 99 instead of 100. And the program can also count the other stars. So here the stars is like here. We can control the size and the position. And for this picture, let's test if the program works. Okay. Sky 2. Copy. Paste and change the picture as Sky 2. Run it again. And we find the 3 connected dots. The reason is besides the 2 star, we also get this strange thing. What it is when I crop the image, I intentionally make a mistake by including a white edge here, and the size of that white edge is 664. That's why we got a more pixels on the dots, and we get an actual abnormal stars. So this time, let me crop the image more carefully. Make sure I didn't include in anything more than needed. Okay, here, sky 3. And paste. Change it as sky 3. Run it again. This time we get 2 stars as expected. That's connected components for graph data.